Hello, seventh grade. This is Mr. Lipscomb. I'm going to talk today a little bit about distribution, why it's true, why it works, and then we will go into some problems that you will be seeing on your homework and classwork over the next few lessons. So let's go straight to the notepad, and let's take a look. So we've talked a little bit about this in class, and we're looking here at two rectangles that are exactly the same size, but in one case we have divided the rectangle into two parts, a part with 3 and a part with 6. But if you'll notice, this entire side still is 9. So what we're going to do is we're going to look a little bit about the area, the size of this rectangle in both cases. So if we think about the area, the size, the part inside the box, and we look at it inside each of these two rectangles, we should realize that they have to be the same size. Okay? And this is the whole key to how we show distribution. And remember, when we look at the size of rectangles, that's just another way that we show multiplication. Okay, remember? So the area of this rectangle is 4 times 9. This is the area. Let me just make this a little bit easier. 4 times 9. So this is our area, which is equal to length times width. Length times width. So the length, we're going to call this the length times the width is 4 times 9. And we notice that that has to be the same as the length of 4 times 3 plus 6, because in one case, the length here is 9, but another way of looking at 9 is 3 plus 6. And clearly, 4 times 9 has got to be the same thing as 4 times 3 plus 6. And we can see that because we know that 4 times 9 is 36. And we know that 3 plus 6 is equal to 9, so 4 times 9 is also equal to 36. So that's what we showed in class. Now let's look at this one other way. Let's look at this a third way, and that is let's just draw this thing one more time, this box, and let's go. Here's our 4 and our 9, and our line that's at 3 and 6. Now the other way to look at this is that the area of this whole thing has to equal the area of the parts. So if this is the whole, I'm going to write whole. And here we got to say, we're going to call this part 1 and this part 2. So the key here is that the whole has to equal part 1 plus part 2. And we're going to use, and this is also the whole. This whole thing is the whole. So we know that one way of looking at the whole is 4 times 9, but the other way of looking at the whole is 4 times 3 plus 4 times 3 plus 6. So let's just write that down for the whole. 4 times 3 plus 6. And then we're going to learn about our distribution here in a second. We're going to do our distribution. But anyway, so let's look at part 1. Part 1, how big is part 1? If it's the length times the width, this is 4 times 3, because the length of this thing is 4 and the width, if you will, is 3. So we have 4 times 3. Now, similarly, we can look at the length, or sorry, the width of this part and the length of this part. And so this is 4 times 6. So our part 1 is 4 times 3, and our part 2 is 4 times 6. So in other words, 36, and so 36 has to equal 12, which is part 1, plus 24, which it does. 12 and 24 is 36. Now, another way of looking at this is we're going to take this piece here, this 4 times 3 plus 6, and we're going to look at how the pattern here and see where the 4 and the 3s, let's just look at where these things appear. This 4 appears here and here, and let's see if you can see where the 3 and the 6 appear. Well, the 3 appears here, and the 3 appears here, and then the 6 appears here, and then again over here. So you have this interesting pattern where 4 times, well, let's just look at it this way. I like to look at it like we end up with a 4 times a 3 plus a 4 times a 6. And that is your law of distribution, is that some number times 2 other numbers added is equal to that first number times the first number plus the first number times the second number. And we've just proved it by looking at these 3 ways of looking at the same rectangle. So let's just take this one step further over here, and let's look at it more generally. So we just said that we'll just do the thing that we just showed, and then we're going to make it more generic. So we say that 4 times 3 plus 6 is equal to 4 times 3 plus 4 times 6. And that's a specific case that we just showed. But you can do this for any numbers. All numbers this is true for. So if I did 2 times 5 plus 7, I could say that 2 times 5 plus 7 must equal 2 times 5 plus 2 times 7. And why is that true? Because these 2 areas, the whole, this is the whole. And this is the part, and this is the other part. So let's see if we can do this next one with a variable. 2 times x plus 4, and let's draw the picture. 2x 4 must equal 2 times x plus 2 times 4. And that's a picture because this is 2x and this is 2 times 4. Looking at the whole, it's got to be 2 times x plus 4 because the length is x plus 4 and the width is 2. But if I look at each individual part, I should be able to add the two parts together and get the whole. Now, I want to show you a few problems that we can solve knowing this. And we can do it either using our rule or using a picture. So let's try a problem like this, where we say 2 times A plus B. Well, we can either use our rule. Well, let's do it. Let's do this one graphically or with an image. 2AB. So our length, our whole, is equal to length times width, and our length is 2, and our width is A plus B. So this is our whole. Part 1 is 2 times A, and so that's the area of this small box. The area of the bigger box is 2 times B. So our whole must equal the part plus the part. So 2 times A plus B equals 2A plus 2B. Now let's look at this. Let's just take this and do it a different way. And let's not draw the picture and see if we can still solve it. And the way that we do that is, rather than drawing the picture, we can just draw our arrows like this. I draw arrows for distribution, and this is a legitimate way to do it. And what we do is we say, well, let's follow the arrow and multiply the numbers. Well, 2 times A plus B, the quantity A plus B, is 2A. As we follow the first arrow, we have 2 times A, and then we're going to take our plus sign, copy our plus sign over, 2 times B. And there, we get the same thing. We get the same thing as we found in our picture. Now note, I want to make this big, strong note. Note, this only works when multiplication is on outside and addition on inside. So be very careful. Some people will try and start to overuse this law of distribution, and we can only do it for each term inside of parentheses multiplied by the thing outside the parentheses. We'll do a couple more examples here. Okay, so we can do it. Let's do 2 times, or let's do a different number. Let's do 8 times x plus 5. Draw your arrow, and you get 8x plus 40. So we're going to multiply across on our arrows, and that's a 40. Okay, let's try it. Now it also works if on the inside you have subtraction, y minus 3. And the reason it does is because it's like addition. Remember? Because that's the same thing as y plus a negative 3. And now that we have addition, we can draw our arrows. And we say 4y plus a negative 12. And you can shorthand it with subtraction. And notice that you end up with the same thing. You end up with 4y copy our subtraction sign across, and then we get minus 12. So, and we know that 4y plus a negative 12 is the same thing as 4y minus 12. So that shows you that an addition or a subtraction can be on the inside and it will still work. It does not work if multiplication or division is on the inside, so be very careful. Let's try another one. 5 times 2x plus 10. Draw your arrows, and you get 5 times 2x plus 5 times 10. Well, we know that 5 times and now that we're in this situation, remember from our earlier lessons this unit, before you combine across your addition sign, you have to simplify each term. 5 times 10 is 50. 5 times 2x is 5 times 2 times x, right? 5 times 2 times x is 10x plus 50. One last problem before we leave, and it's that you can do this with 3 terms too, and let's watch how that works. 4 times x plus y plus 3. And you can see it working the same way as we've done before, where we draw our picture, and we have an x, a y, and a 3. So the length on the top is x plus y plus 3. And the width is 4, so we have another case of our length times our width. This is our whole. And now we have 3 parts. We have a part that's 4x, 4y, and a part that's 4 times 3, or 12. So this equals 4x plus 4y plus 12. Whole equals part 1 plus part 2 plus part 3. Okay, hopefully this was a useful lesson. This is distribution. We've done this in class, so this is just not maybe a lesson that you can learn from scratch and totally get it by the end, but I wanted to show you how distribution works graphically, or from a visual point of view, and then from an algebraic point of view with arrows, how to work a few problems. And I'll be seeing you in class, and let me know. Come see me if you have any further questions. We can work lots more examples, and I'd love to work with you one-on-one if you need some extra help.